Very good morning. We were talking on dependent sample t-test this week, and continuing with, you can say, exercise 7, we'll be today talking about question number 2 and question number 3. Talking about question number 2, air traffic controllers often experience a high degree of on-the-job stress. In an effort to help traffic controllers cope up with the stress, the impact of relaxation exercise program was investigated. 35 traffic controllers were selected from some of the biggest airports in the country and were administered a scale measuring job-related stress. The scale ranged from 10 to 50, with the higher scores indicating greater stress levels. Following the administration of the stress scale, the air traffic controllers were trained in relaxation techniques for 4 weeks and then were administered the job-related stress scale a second time. The data are in the file 7 exercise 2. The variables are named pre-relax, post-relax. So we have to open the file in SPSS and perform the appropriate analysis to the answers in the, like you can say A, framing the hypothesis, B, talking about research question, 3, C part is basically you can say stress levels are different after relaxation exercise training as compared to before at alpha is equal to 0.05, effect size we have to talk, and finally we have to talk about the APA format results are to be mentioned. So this being the question, we just will you can say talk a little more about the question. It's about you can say air traffic controllers who are having a very high level of on the job stress. So 35 air traffic controllers have been selected where they have been provided with stress and impact of relaxation exercises, and after that exercise you can say before and after you can say the exercises there has been measurement of job related stress. So we are just trying to check out that okay fine pre and post level of stress of air traffic controllers post pre and post you can say the training exercises. So what I'll do is I'll move to the question as a share. So we are moving to the exercise. So we are moving to exercise. Here I change the share. So here the question is, this is what the question is. We have got the pre-relax and post-relax as two variables for the same air traffic controllers, 35 in all, and this is it. So it's, sorry, it's 30 actually, not 35. So 30 there. And then we are talking about the variable view. Here we have got the variable view where the post-relax and post-relax, pre-relax and post-relax are the two variables which are to be can say compared in this comparison, or you can say a peer test, or you call it dependent sample t-test. So we are going for analyze, we are going for compare means, we are going for this paired sample t-test, and then we have got the post-relax as variable 1, pre-relax as variable 2. We click on OK and we are getting the answers. And I'll make you sure that we are in the output file. So we are having the output coming up. So this is what the output is. So this is the answer we have got here. So we have got, you can say pre-relax, the mean is 36 something, post-relax, the mean is 34 something. N happens to be the number of people who have been selected. So we have selected 30 people in each of the cases. Standard deviation is 9.75 for pre-relax and 8.78 for post-relax. As far as the, you can say, the stress level is concerned, pre-relax and post-relax, it is coming to be very, very significant. It is almost 99.9% significance is, confidence interval or 0.000 significance level is there, which means that higher the you can say higher the stress, lower the stress level in the initial stages, that is before at the pre-relax stage, lower would have been you can say the stress post you can say those exercises, and even if it was higher initially, it would have remained high later on also after training exercises. So that's there. Now that is one thing, and then we have got the paired sample final test coming up, where the mean you can say mean difference happens to be 1.4, standard deviation happens to be 3.69, so that's there, and t value happens to be 2.077, degree of freedom is 30 minus 1, that's 29, and significance happens to be 0.047. So let's look at the answer now from, you can say, from exercise 7, question number 2, A part, state null and alternate hypothesis. Null hypothesis: there is no difference in the stress level of air traffic controllers pre and post relaxation exercises. You can also write null hypothesis this way: H null colon mu pre-relax minus mu post-relax is equal to 0. Altered hypothesis: there is significant difference in the stress level of air traffic controllers pre-relax and post-relax, the training exercises, relaxation exercises, which can also be written as H alternate colon mu pre-relax minus mu post-relax is not equal to 0. Coming to B part, we are talking about the research question. The statement is there a difference in the stress level of employees? Is there a difference in the stress level of air traffic controllers before and after the relaxation exercises? Question mark. Now coming to the C part of the question, where we have to talk about the analysis part. And here, if you look at the value of T, it comes to 2.077. And if you look at the value of significance or small p, it comes to 0.047. So this value is lower than 0.05. So we'll be accepting the alternate hypothesis. This means there has been surely a difference in, you can say, the pre-stage and the post-stage, you can say, stress level after the relaxation exercises have been conducted. Now coming to the next part, where we are talking about the effect size. Effect size in case of dependent sample t-test is, effect size is denoted by small d. So small d is equal to mean difference upon standard deviation. This means 1.4 is being divided by, we are dividing 1.4 by 3.69, and the answer we are getting is 0.38. So 0.38 happens to be the d value, and if you look at this d value, this is near to smaller, you can say, near to small, what do you call it, small effect size, because if you look at the d value, if it is near to 0.2, it is low or small. If it is 0.5 or above, it is supposed to be medium or average, and if it is, you can say, 0.8 or more, it is supposed to be large or great. Now in our case, you can say this value comes to 0.38, so we'll call it, you can say, a small effect size. So we have solved question D part also. Now coming to the last part of the question, where we'll be talking about the actual, you can say, how we are interpreting the results. Stress level reduces significantly from pre-relax stage within brackets m is equal to 36.23, comma SD is equal to 9.76, bracket close, to the post-relax within brackets M is equal to 38.83, comma, SD is equal to 8.78, bracket close, comma, small t within brackets 29 is equal to 0.2077, comma, p, small p I mean, is less than 0.05, comma, d is equal to, small d is equal to 0.38. So that's the answer for question number 3. And let's now start with question number 3 of the same exercise. So exercise 7, question 3 we are doing in a while. Now looking at this question number 3, which is about sports, and we have been fairly talking about sports in our business search lab, you can say, questions. We had a question on, you can say, football few weeks back, when we were talking about, you can say, whether you're going for you can say kicking the football by from toes or by heel, and which technique is more effective. Now today I'm talking about, you can say, question on you can say how you can say the accuracy of shots is to be seen for tennis players. So let's read the question now. A researcher investigated the impact of receiving training from a sports psychologist on the accuracy of shots of the college tennis players. The shot accuracy of 15 tennis players was recorded before and after receiving 8 weeks of training from sports psychologist. Accuracy scores ranged from 0 to 100, with higher scores indicating greater accuracy. The data are in file that is attached to you, and the variables are named before training and after training. And we have to again do the same questions like stating the null and altered hypothesis, writing down the research question, seeing which hypothesis is to be, you can say, accepted, whether it's null or the alternate, then effect size, that is the D part, effect size I'm talking. And lastly, we have to talk about how are we going to write the results in APA format. So that's the question. Let's look at the question once again. So here we have tennis players, and we have got 15, you can say, tennis players of school, of college, who have, you can say, been given a training on, you can say, how to have effective shots to be made. And they have been, you can say, the data has been, you can say, recorded prior to you can say the training and after 8 weeks of training. And therefore the variables are named as before training and after training. And the actual scores, you can say, of training, before training and after training, range from 0 to 100, with higher scores indicating greater accuracy. So that's the question. Moving to the question, you can say, in the SPSS file. So I have opened the SPSS file for you. Here it is. So we have this SPSS file coming in front of us. So we have the data view here. So before training, the value of 15 players is given. After training, the value of 15 players is given. The higher the value that's actually happening is showing that, okay, fine, the players have improved. If the value has deteriorated, that it was 94 initially, moving to 92 now, this means the player has not done well or gone well with the training program. So we are just seeing the effectiveness of the training program, but the training program has been effective to actually overall improve the, you can say, the shots of the tennis players. Coming to the variable view here, we have the two variables before training, after training, and then both of them are in scale measure. So that's there. Now coming to the analysis part, I'm going to analyze, going to compare means, going to pair sample t-test, clicking on it, and then before training is being, you can say, put up here as variable 1, after training as variable 2. And I'm simply moving to something called OK. And while I move to OK, I know I have to change my share also. So I'm changing the share to the output file, and here I'm getting the answers. So the answers are before you. So we've got before training mean as 85 something, after training 89 something. This means there has been an improvement as far as, you can say, the accuracy of shots of these players, 15 tennis players of the school were concerned. SD is, you can say, 6.4 before training and 5.7 something after training. If you look at the correlation, that correlation is also high. If players were having high shots, you can say, accuracy initially, they again have had, you can say, a high shot accuracy later on also. So that's the correlation. Okay, it's very, very significant. That's not the part of the actual analysis, but then, okay, fine, we're talking on this. Now coming to the part of, you can say, answering the questions now. A part, state null and alternate hypothesis. Null hypothesis, there is no significant difference in the accuracy level of college tennis players pre and post training program. You can also write it this way, that H null colon mu before training minus mu after training is equal to 0. Alternate hypothesis, there is significant difference in the shot accuracy level of college tennis players before and after the training program. H alternate colon mu before training minus mu after training is not equal to 0. Coming to B part, we are talking on the research question. Is there a difference in the accuracy level of college tennis players before and after the 8 weeks training program? Question mark. C part. We are talking on something called the acceptance of hypothesis. If you look at the t-value comes to, you can say, minus 3.862. T-value comes to minus 3.862. Significance is 0.002. So we'll say we are accepting the null hypothesis. Sorry, we are accepting the alternate hypothesis as a t-value is 3.862 with a significance or small p-value of 0.002. That is, the confidence interval level happens to be 99.8%. Done? So that's there. And coming to, you can say, the D part, where we are talking of effect size. If you look at the effect size is, you can say, the mean difference between before training and after training, which is 4, divided by the standard deviation, which is 4.21, which we can see from here, both the values. So 4.2 divided by 4.21 comes to nearly, you can say, 1.0. The answer will come to nearly 1.0. So I'm assuming you can say it as 1.0 only. So effect size happens to be 1. This is what I'm saying. Small d is equal to 1. Now, if you look at the notes also, please try to, you can say, read the notes, and you will definitely get all the explanation there. That if d is 0.2, we are supposing the effect size to be small. If it is, you can say, 0.5, we are supposing effect size to be average. If d is equal to 0.8, we are supposing effect size to be large. In our case, you can say effect size happens to be large because it is higher than 0.8. So we are saying effect size is large. Okay. Now coming to, you can say, the C part of the question. Sorry, the D part of the question. Sorry, E part of the question, the last part of the question, where we have to talk about the interpretation, final interpretation. Though I've already said that, okay, null hypothesis is not accepted. We are accepting the alternate hypothesis. So we are writing this now. There has been a significant improvement in accuracy of tennis shot before training. M is equal to 85.07, comma, SD is equal to 6.46, to after training. M is equal to 89.27, comma, SD is equal to 5.7, comma, small t within brackets 14 is equal to 3.862, comma, small p is equal to, small p is less than 0.05, comma, d is equal to 1. So this is how this answer has to be written. You can look at the answers on your own and check your answers which you have done previously. So I suppose we have learned something about peer test or dependent sample t-test this week. Hopefully you have enjoyed these 3 questions. So have a nice time. And next week, we'll be talking with a new topic. Goodbye, Tindel. Goodbye.